Alright, let's look at the homework 7.8, problem number 9. Alright, so we want to use the comparison theorem to determine this given improper integral is convergent or divergent. Alright, so let's do that. Alright, so we just need to simplify this guy a little bit. So let's start with the original one, 46. Just a number, arctangent. So you have an arctangent of x over 2 plus e to the x. Alright, then remember the arctangent is always between negative pi over 2 to positive pi over 2. So I'm going to replace it by pi over 2. So 46 is just a number. And I'm going to put the pi over 2. And we have a 2 plus e to the x. Right? Since we make the numerator largest possible, so it's going to be definitely greater than or equal to the original one. Right? And we can do a little bit better. We can actually drop this 2. Right? Since we are making the new denominator smaller by eliminating 2, the whole fraction is going to get larger. So we have that. All right. Then I guess we should simplify. So 2 and 46 cancel out, and that's a 23 there. All right. So this is just 23 pi over e to the x. Alright, so let's, instead of the original one, let's work on the larger function. So we look at the integral from 0 to infinity of 23 pi. So this is just going to be a number, so 23 pi. I would just kick that guy out of the integral. Then 1 over e to the x. I'm going to actually write it as e to the negative x. Right, and dx. Right, so this is going to be, so we have to write, so 23 pi, just a constant. Since this is an improper integral, I'm going to replace infinity by t, and the 0 is okay. And then we take the limit as t approaches infinity. Right, then we have e to the negative x with respect to x. Alright, so this is going to be equal to 23 pi, and we'll take care of the limit later, limit as t approaches infinity. And the antiderivative of e to the negative x would be e to the negative x over negative 1. So I'll just put the negative sign right here. Alright, then you're going from 0 to t. And this is equal to 23 pi, right, and limit as t approaches infinity, and plugging t there, so we have, let's see, we plug in t, so it's going to be negative, right, negative power, so it's a reciprocal, 1 over e to the t, right, minus, there's a negative sign, so it's going to be plus. Plug in 0, e to 0 is going to be 1. Alright, so we have that. Then we can take the limit. Alright, as t approaches infinity, e to the t approaches infinity, which means that the 1 divided by infinity. So you can see that the first term is going to approach 0. Alright, so what we get is you have a 23 pi times 1. Alright, so we have a 23 pi. Alright, so we could see that the larger function, the improper integral, converged. Alright, which means that the original function is actually even smaller. So therefore, we know that this original integral, improper integral, is going to converge. So this is going to be convergent by comparison test. So we can make this conclusion by comparison I guess they call it comparison theorem. Alright, let's double check and go here, and it's going to be convergent. Submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.